Welcome to the Valor Division's webinar on process preparation. My name is Mark Lane and I have been in the process preparation team of Valor for over 10 years. I thank you for attending and will be giving you an overview of both current capability and what's coming in the next release. There are many challenges preparing PCB assembly collateral. There are different areas to consider, including design for assembly, pick and place machines, inspection machines, test machines, as well as manual placement stations, as different software can be used for these different areas that drive different files that form the starting point to each machine. Multiple libraries are then needed to be managed across these different machines. All these variations cause opportunities for inconsistent or incorrect machine programs across the PCB assembly line, as we will see in more detail on the next slide. Most PCB assembly machine vendors deliver software to process CAD data. Typically, these software packages are optimized to read certain types of design information. This can be Gerber files, intelligent CAD, or generic manufacturing files, such as GenCAD. Think about your PCB manufacturing environment and consider how many places electronic design data is processed with machine-specific software. How many people in your organization are doing very similar steps to import design and bill of materials files as a start to programming machines? How much effort is being wasted in these duplicated tasks? Given all of these times design and BOM data is processed, can you expect that consistency will occur every time? Chances are that it will rarely work as intended most of the time. All these areas contribute to the true cost of free software. Surely there must be a better way. The final PCB can be described with a single container for all common data, regardless of the various machines and outputs we need to support. This establishes a single point of truth that all process collateral can be created from. Regardless of the machine being used, board, part, package data is common. If we are able to use a single application to manage all PCB assembly collateral, we can accelerate the NPI times as we only need to perform each task once. This eliminates redundant steps as well as increasing efficiency through automation, learning libraries, and the use of templates. Line utilization will be improved through the maximizing of offline preparation work and virtual sticky tape. This reduces the online trial and error, hence improving line utilization. By capturing the manufacturing know-how centrally, tasks performed by one engineer can be shared with other engineers automatically. That way, all engineers benefit from the work that's been done by others. When products need to be moved from one facility to another, usually the NPI phase needs to be repeated. This is because the target line is different from the existing one. However, for efficient NPI processes, it should be possible to deliver that same common data set to the other factory, so they don't need to perform the NPI steps again. Let's see how Valor Process Preparation delivers on these requirements in the latest and recent versions. Process Prep supports all the common input formats. There is a simple BOM import wizard, panel creation, along with automated fiducial, test point, and badboard reject mark identification. We support reading all Gerber formats and can use that for reverse engineering unintelligent data to intelligent data. If I have intelligent CAD but incomplete Solder-mask data, I can overlay Gerber mask data over the intelligent CAD to replace the CAD mask data. Continued support of imported CAD and CAM formats is critical to seamlessly getting data into a process engineering application. We recently added IPC 2581 and then followed up with revision A and B of this format. ODB has been updated with versions 7, 8, and 8.1. Zuken has updated CR5000 to CR8000 Board Designer. New in 12.8 was the ability to drag and drop a CAD file onto the client and identify that file automatically. Since Mentor was acquired by Siemens, we have focused on integrating with a number of Siemens products, and one of those is Teamcenter. As Teamcenter manages all the data and revisions, it enables a left-shift process planning methodology to allow them to work in a virtual environment early in the process. Data is now managed centrally in Teamcenter, is imported to process prep, and then the manufacturing collateral authored before being pushed back to Teamcenter to be deployed. Teamcenter provides a system that manages variants in an intelligent way to avoid the need to perform the NPI processes for each variant, which would be a huge overhead. Since all of the product design and process engineering is in Teamcenter, it is possible to perform an analysis that would allow an accurate estimation of the impact for changing a part, a tool, or a line for an existing product. CAD and BOM data can be imported directly from Teamcenter. Filters exist to narrow down the specific product needed. There are many areas within process prep where we leverage the power of learning libraries. We may need to accept user input to enter specific information if it is not available from the CAD or BOM. But we don't want to have to enter that information each time. The learning libraries allow this data to be stored for reuse on other projects. As more and more designs are processed, the learning libraries reduce the programming times on future boards. Valor has developed a central part and package library that describes manufacturer part number specific information. This gives process prep a source of package information that is not available from CAD. The VPL data can be used in many areas of process prep that need to know the exact physical package information of a part in the BOM, including alternates. Process prep can use VPL data as a source for pick-and-place machine-specific parts, inspection parts, assembly documentation, stencil design, design for assembly analysis, and keep-out areas for test programming. Valor has always been known for world-class DFM analysis, and process prep has an assembly-focused module containing all common assembly checks, such as component-to-component analysis, fiducial analysis, and pin-to-pad analysis, to name a few. These DFA checks are there to ensure that assembly issues are found before products make it into production. Stencils are usually created by stencil vendors interpreting the stencil rules. This can result in a lot of back and forth to get the desired result. Other stencil design solutions mean editing apertures directly, but process prep creates reusable stencil rules based on footprints that use the intelligence of the source CAD and give free capability to apply rules that can be quickly applied to other designs. Using the CAD and VPL, the Stencil Design module gives an accurate representation of how the stencil aperture looks relative to all the pertinent data. Providing access to parameterized stencil symbols allows apertures to be created quickly and accurately. A comprehensive list of standard symbol types can be adjusted to create the common stencil apertures. If a very specific stencil aperture is needed, complex shapes can be created to achieve the desired result. A number of parameterized symbols have been added in process prep. This allows common stencil shapes to be created quickly and easily. Large ground pad apertures need to be split up into smaller apertures to create a window pane. The stencil module can detect this and automatically split them up. There are also many exporters to SPI machines that need to consume the intelligent stencil data and not unintelligent Gerber files. This shortens the programming on the SPI machine, as well as increasing the accuracy of the resultant program. Another area of significant ongoing support in process prep is SMT Programming. Process prep manages the part and package data in addition to the placement information using machine-specific data. New parts can cause challenges in first article runs, and process prep can automate the creation of machine-specific part and package data based on the VPL. If a line uses vendor A and that product needs to be moved to another line using vendor B, it is a simple drag and drop from the source line to the target, and all data is automatically transformed to the target line, including all the machine-specific information. Another area where we are making significant improvements is optical inspection, or AOI. We have worked with a number of AOI vendors, as you can see here, to deliver a much more richer content that can significantly reduce the programming times on AOI. Simple centroid data takes just too long to program AOI machines, so we deliver data that is much similar to that which pick-and-place machines read. ODB++ Process is now part of the ODB++ family that covers design, process, and manufacturing. This machine-neutral XML data contains all the information needed to drive a PCB assembly line, not just the board itself, but all the components on it too. We have machine vendors such as Panasonic, Koh Young, and Vitrox using ODB++ Process to shorten their programming times. The SMT vendors are constantly improving their machines and supporting software. Here's a number of recent enhancements that keep process prep up to date in support of all common SMT vendors. It is important that we keep process prep up to date with respect to SMT vendor software to deliver the best experience we can between our application and SMT equipment. The template-based documentation module offers intelligent work instruction documentation to use on the shop floor. These can quickly create color-coded drawings along with tables and other graphical objects in a fast and efficient manner that deliver quality documentation to the needed stations. Our test program solution has been enhanced significantly over the past few releases and will continue to improve further as we develop this solution. Test programming supports both ICT and Flying Probe machine types, now supporting the VPL data to automatically create accurate keep-out areas for test access. Copper, mask, and component data is analyzed to ensure that the optimal probe placement solution is created without having to tell the software what the correct solution is. The feedback can be provided to designers to improve a layout before it is finalized, or used to maximize coverage with accurate tester-specific output files. For longer-term process prep users, you may still be using the test probe placement session. Please use the test assembly that is now available directly from the assembly node. Right-click and select Create Test Assembly. That will create the test assembly, and now you can use your DFT capability. For example, edit DFT package outlines, where we have added new capability to manage component outlines, including VPL support, as well as improvements to the test probe placement engine with new options. As we can see here, there are many enhancements in test programming. VPL data can now be used for automatic component keep-out areas. Test probe offsets have been improved to better optimize the probe location. Many new test-specific reports have been added. Where supported with specific testers, panel support has been added along with height analysis for flying probe testers. When SourceCAD has inaccurate solder mask information, Gerber layers can be used to replace it. Test probes can be quickly drag and dropped within the exposed metal area, either individually or with multiple probes together. PDF schematic cross-probing is now possible in both the graphical view and the device list. Let's now look at the upcoming version of Process Prep, version 12.9, coming in a few weeks' time. This version of Process Prep adds more enhancements to the existing capability as we streamline and improve the overall user experience, as well as keep up with wider changes in the industry as our customers deploy new machines to their factories. OIB has been the preferred method to create a bidirectional link between Process Prep and ASM pick and placement machines. We further improved this connection through OIB in this new version. Likewise, for Mycronic pick and place machines, we have improved our support through TPSys. We have also added support for panel level components for SMT programming. For test programming, we have added two new machine formats in Takaya CAX and Teradyne XML. Furthermore, in the test programming area, we have significantly improved the graphical results viewing capabilities, as we shall see. Let's start with data preparation improvements. Our SMT flow is BOM-centric, meaning only parts in the BOM are considered. There are times when an SMT flow needs to manage parts that are not placed, such as for optical inspection. Now unplaced or no-pop parts can be easily managed even though they are listed in the BOM through the new automatic no-pop component capability. The Stencil Design module has received a number of changes. Let's review them now. We now support both standard and special symbols. However, once a special symbol was created, it was contourized to an outline, and that made it difficult to edit afterwards. Now, special symbols retain how they were created, making future adjustments much easier. The special symbol editor now has undo and redo capability, and special symbols now can be transformed in the same manner as standard symbols. Stencil technologies, or rules, were part of the first release of the Stencil Design module, but in 12.9 we have given our users more control on managing these libraries. Now you can see and manage the stencil rules, and therefore copy a rule from one technology to a different one directly, and so not need to create a rule in a technology when that rule exists in another one. It is common to want to add text to a resultant stencil, and now that is supported within the Stencil Design module to quickly add label text that will show on the final stencil layer. Next, we will look at SMT enhancements. The ASM interface is one of the most popular SMT machines that we support. As a result, we receive enhancement requests such as these ones. Here we support new dynamic properties for the top and bottom paste height. Here you can see the data managed in process prep on the left, and that data once it has been transferred to ASM C-Place through OIB on the right. The ASM count panel option is either enabled or disabled. This option can now be set in process prep and passed to C-Place through the OIB interface. Finally, for the OIB interface, we now support electrical part characteristics. These are again shown in the left side in process prep, but also on the right side in C-Place. For the Mycronic machine interface, formerly known as MyData, we have added support for newer versions of the TPSys interface. We have also added new library fields to this same interface, as shown here. Now we will look at the test engineering enhancements. We have supported Takaya Flying Probe machines through the CA9 for many years. However, once Takaya released the double-sided Flying Prober, the 1600 series machine, the CA9 wasn't able to support the testing of components that needed to be probed on both sides of the board at the same time. Therefore, Takaya introduced CAX as the new format that replaces CA9 specifically for double-sided requirements, though it can also be used for single-sided 1400 series machines. This new exporter also shows a new capability relative to test library management. Now, machine-specific tests can be managed through tester libraries that will be available for other machine formats as we add them. Seica selected Process Prep a few years ago to be the front-end data processing solution for Viva, which is their program development application for their Flying Probe machines. Now Process Prep also supports the ICT machines from Seica, both multiplexed and non-multiplexed systems. In conjunction with Seica, Process Prep further improved the data being delivered to Viva that reduces the time in assigning complex tests. New in 12.9 is a capability to graphically review the test probe placement results by use of the PCB Navigator. A new window can be viewed that lists the active net results that links to the graphical view and PCB navigation. The net results can be narrowed down through existing component, pin, and via navigation. A number of ways are available to review DFT results. Graphically, click on a pin or via and the specific results for that feature will be displayed. In component or net mode of the PCB Navigator, click on pins, vias, or nets. Use the built-in filtering to further reduce nets that have many connections to focus down to the connections that are of interest. Here we have a board, we've run the analysis, we have the probe placement results at the bottom of my graphical window. If I now click on a net in the PCB Navigator, we see all the results of that net. However, I can go in to the tree underneath that net and click on each of the features one by one, and the tool will filter that list down to just what I'm looking at. Pick another net, and again, resets, shows me all the results. So this keeps us in that same environment, in the same graphical area with the PCB Navigator looking at all the results together. In previous versions, the probe locking was added, and now that we have been updated in 12.9 with new attributes that inform the user of the source of a test probe. The four states are imported, for those that were imported from a CAD file, automatic, for those that were placed by the probe placement engine, manual, for any probe that was manually changed by the user, and forced, for probes that were placed using the force probe capability. The probe locking was updated to use the manual probe source attribute depending on user preference during subsequent probe placement runs. Teradyne introduced a new XML format to program their range of ICT machines. Process Prep now creates this compatible XML file that delivers full information to these test systems. Process Prep supports all the prior machine formats, so the XML completes support for all recent Teradyne and Genrad testers. Thank you for attending this webinar. I hope you found it interesting and informative. We will now open it up for questions.